Good day, my name is John Vincent S. Saracanlao. You can call me Sir John or Dr. Saracanlao. Our lesson for today is on descriptive research and descriptive statistics. According to that, descriptive research is considered the most appropriate in studying situations that have occurred or existed. It is concerned with the conditions that exist, practices that prevail, and beliefs that are held, and the processes that are going on, effects that are being felt, or trends that are developing. It is a process goes beyond mere gathering, tabulating data. It involves analysis, interpretation of meaning or significance of what is being described. Generally, in descriptive statistics, these results come in the form of mean, frequency, percentage distribution, and standard deviations. Measures of central tendency like mean, median, and mode, and graphs, pie charts, and bar graphs that describe the data are also tools in descriptive statistics. One significant feature in descriptive research or statistics is being fundamental. Causal, comparative, and correlational research or statistics are done after descriptive research or statistics is conducted. Descriptive statistics include procedures used to describe the population being studied. The data can be collected from either a sample or population, but the result helps the researcher organize and describe the data, sample, or population. However, descriptive statistics can only be used to describe the group that is being studied, which means that when you have data in your research and you're describing the data, it is not technically correct to infer it to a whole. For example, your data is within this location. True that the data is describes that area, but it does not permit or suggested that you infer that it is across other areas or it is the same with other areas. By probability, there might be the same, but that's where inferential statistics comes in because you can infer from outside, not just describing the data itself. So there are actually a lot here. We have mean, frequency, percentage distribution, and standard deviation. I'll talk first about mean and standard deviation because this is very basic but very misunderstood in terms of its real value. So mean is basically your average. So it's a sum of values distributed divided by the number of values. So it's just sum of values and divided by n. So that's how you do paper and pen using mean. And for standard deviation, it's the square root of the quotient obtained by dividing the sum of the squares of deviations of the observations from their means by one less than the number of the observation in a sample. That's very highly technical. So that's a formula. That's how you solve your standard deviation. That's your mean and square that mean, and you have your sum of mean, and you just have your formula here, and you just follow the formula. But we're not getting through that. This is not a class. It's more of a crash course in the content. So let's go. I'll discuss this implications of mean after we do the calculation. So mean, so it's in the book there under data, the cell here. You put just average, and you just highlight the scores, and that's it. You have your average. And for standard deviation, you just put SDDev, then that's the standard deviation. Look at the standard deviation here. Let's go to the mean. Mean is very simple. It's just an average. But standard deviation paired with the mean has a the standard deviation itself is a concept that need to be understood fully. So when you say 1.7 based on the parameters, that means the responses vary a lot from each other. They're not the same. So when we change that to 5, or 4, no, wait, let's say 4, you will notice that the change from very different to similar, somehow similar. And if we change that to 5, that will make a standard deviation of 0, which means the responses or the scores are very close to each other. So when you go back again to the data, like so 5, 6, 7, 8, 9, 10, you will notice that the standard deviation increases within the parameters. That means their responses are not the same to each other within the mean. So let's say we will change that to 5, 6, 6, and we'll have another 4, 4, and 5. Still here, it says it varies, but not as much anymore within the mean. So basically, when you talk about standard deviation, you're talking about the distribution or the variation of the scores or responses. And this is very important because when we say that, let's say the mean of 5 is considered is fair, that's good. The performances, let's say these are performances, the performances of the respondents are fair. But when we say that 5, 5, it's 10, 10, 10, 10, 0, 0, 0, let's say that's 5. That's still the same result. It's 5, it's fair. But look at the standard deviation. Standard deviation indicates that they are very far from each other. What does that mean? So even though our average is 5, standard deviation indicates that they don't have the same scores or they don't have the same responses. And that alone, when we talk about averages, averages should always be paired with standard deviation simply because we cannot, I don't think it's a fair conclusion that, let's say, the students here or the respondents here are just fair because actually it's not fair. So there's 3 students who got 10 out of 10 and one student 5 and another 3 0. So is it fair to say that these students are fair or the responses are we generalize them as fair when in fact they're not? It's just the full the scores are it's a mean. The mean is went to 5, but we all know that it's just an average. And when we say like 5, 5, 5, 5, 4, 4, 6, and let's make this to 4, no, 6, that's 5. So, but here in this case, our standard deviation tells it varies, but not a lot. So this means that it is fair to conclude, in a sense, not in an absolute sense, that the respondents in that area or the responses are categorically fair or by group fair. So that's the importance of mean and standard deviation. I hope you get my point because some people just look at the average without looking at the standard deviation. And the standard deviation has so much implication when it is paired with the mean. Yes. And for standard deviation, it's in the book on how to get it. And I have to cut this off because I will be discussing frequency, percentage distribution. We also have ungroup data and group data, and ungroup data using Excel as well as group data and ungroup data using Excel. And so that's a lot of topics to be discussed. So as for now, I'm gonna end this video and consider it as a lesson on mean and standard deviation, and I will add another lesson in a couple of minutes. So I guess that's it. Thank you for watching, and I hope you learned something today.